You're sitting quietly, minding your own business, and suddenly hic. Your whole body jerks slightly. You have no control over it whatsoever. A few seconds later, it happens again, and again, completely against your will. So what is actually happening inside your body during a hiccup? The answer traces back to ancestors that lived in water long before humans existed. And it involves a reflex so oddly specific that scientists still debate its exact original purpose. There's even a real device, backed by actual published research, designed specifically to stop it. Let's get into it. Let's start with exactly what happens physically during a hiccup. Your diaphragm, the muscle beneath your lungs that controls breathing, suddenly contracts sharply. That sharp contraction pulls air in quickly, faster than a normal breath. Almost instantly afterward, your glottis, the opening between your vocal cords, snaps shut. That sudden closure interrupts the incoming air, creating the sharp, familiar hic sound. The entire sequence takes a fraction of a second, and you have essentially zero conscious control over it. This isn't random, though. It's a coordinated reflex involving specific nerves and brain regions. Two major nerves are involved, the phrenic nerve and the vagus nerve. The phrenic nerve controls the diaphragm directly, triggering that sudden, sharp contraction. The vagus nerve helps coordinate timing and connects to structures throughout your throat and chest. Both nerves report back to a loosely defined hiccup center in the brainstem that ties the whole reflex together. It's a genuine, coordinated reflex arc, not just a random muscle twitch happening on its own. This also explains why you genuinely cannot stop a hiccup through willpower alone. The reflex arc largely bypasses the parts of your brain responsible for conscious, voluntary control. It's similar to how you can't consciously stop your knee from jerking during a doctor's reflex test. Your brainstem essentially runs this specific program on autopilot, without asking for permission first. That's exactly why yelling at your own diaphragm to stop never actually works. Certain everyday situations are well known to trigger this reflex more easily. Eating too quickly, carbonated drinks, and spicy food are some of the most common culprits. Sudden temperature changes, swallowing air, and even excitement or stress can trigger hiccups too. Most of these triggers share something in common. They irritate or stretch the stomach, diaphragm, or throat. That irritation is often enough to set off the entire reflex arc we just covered. Now here's the genuinely fascinating part. Why does this specific reflex even exist in the first place? One of the most well-supported scientific hypotheses traces hiccups back to our amphibian ancestors. Specifically, researchers compared hiccups to how tadpoles breathe using both gills and developing lungs. Tadpoles pump water across their gills, but they need to keep that water out of their developing lungs. They do this by sharply closing their glottis while pumping water, a motion remarkably similar to a hiccup. A landmark 2003 study proposed that humans may have inherited this exact ancient neural pattern. Supporting evidence includes the fact that both hiccups and tadpole gill gulping are suppressed by high carbon dioxide levels. It's a genuinely compelling case that a piece of our amphibian past is still quietly wired into us today. There's an extra clue supporting this idea, hidden in the nerve pathway itself. The phrenic nerve, which controls your diaphragm, starts up near your neck, not near your chest. It then travels all the way down through your chest just to reach the diaphragm below your lungs. That's a strangely long, indirect route for something so important to breathing. Evolutionary biologists explain this as a leftover from fish ancestors, whose gills sat much closer to the neck. As our body plan changed over millions of years, that nerve simply kept its ancient, inherited path. Hiccups may be a leftover behavior. This nerve detour may be a leftover blueprint. Both point to the same deep history. To be fair, this isn't the only scientific explanation being seriously considered. Another researcher, Daniel Howes, proposed a different hypothesis focused on infant feeding. He suggested hiccups in nursing infants might help expel trapped air from the stomach, almost like a built-in burp. This would help explain why hiccups are especially common in babies, who swallow a lot of air while feeding. Both explanations are taken seriously by researchers, and they aren't necessarily mutually exclusive. Here's a detail that connects nicely to both theories. Babies actually hiccup before they're even born. Ultrasounds regularly detect fetal hiccups starting fairly early in pregnancy. This happens well before a fetus needs to breathe air or feed in the way a newborn does. Some researchers believe this early hiccuping might help develop and practice the breathing muscles before birth. It's a small, quiet form of practice for muscles that will soon become essential the moment birth happens. Interestingly, hiccups appear to be limited mainly to air-breathing mammals. Reptiles and birds, despite also being distant evolutionary relatives of early tetrapods, don't seem to hiccup at all. Their respiratory systems developed along a different evolutionary path over time. This actually supports the idea that hiccups are specifically tied to the particular path mammals took, not a universal trait. This nerve pathway understanding recently led to something genuinely useful, an actual tested device. In 2021, a neurosurgeon developed a straw-like tool designed to interrupt the hiccup reflex directly. It works by combining strong suction with swallowing, engaging both the phrenic and vagus nerves at the same time. A study published in JAMA Network Open found it stopped hiccups in about 92% of reported cases. It's worth noting this was a preliminary, observational study, not yet a large-scale controlled clinical trial. Still, it's a rare case of old folk remedies getting a genuine, published scientific evaluation. Before modern medicine, people across many cultures developed their own creative ways to stop hiccups. Drinking water upside down, holding your breath, and getting suddenly startled are all classic, widespread examples. Many of these remedies actually share a common thread with modern scientific understanding. Most work by either raising carbon dioxide levels or physically stimulating the vagus nerve somehow. So while Grandma's remedy wasn't backed by a lab study, it may have been working on real nerves the whole time. It's a nice reminder that folk wisdom sometimes stumbles onto real biology long before science catches up. Quick pause before we continue. Take a guess. Do you think being suddenly scared actually helps stop hiccups, like the old folk remedy claims? It might work sometimes, though not through magic. A sudden startle can interrupt the nerve signals involved. But there's no strong, consistent scientific evidence that it works reliably for everyone. Let's clear up a few common myths before we wrap up. Myth 1. Holding your breath is scientifically proven to be the best way to stop hiccups. Not quite. It may help by raising carbon dioxide levels, but it isn't reliably proven as the single best method. Myth 2. Hiccups only ever happen after eating or drinking something specific. Not true. Stress, excitement, and temperature changes can trigger them with no food involved at all. Myth 3. Prolonged hiccups are always harmless and never indicate a medical issue. Not accurate. Hiccups lasting more than 48 hours can sometimes signal an underlying medical condition. Myth 4. Reptiles and birds hiccup too, just less noticeably than mammals. Not accurate, based on current research. This reflex appears to be largely limited to air-breathing mammals. Myth 5. Adults get hiccups far more often than babies do. Actually the opposite. Babies and fetuses hiccup remarkably often, far more frequently than most adults do. Myth 6. A hiccup and a burp are essentially the exact same bodily reflex. Not accurate. They involve different muscles, different nerve pathways, and serve different physical purposes. Let's wrap up with a few fun extra facts. The longest documented hiccup case in medical history belonged to an American farmer named Charles Osborne. His hiccups reportedly lasted an astonishing 68 years, from 1922 until 1990. Despite this, he lived a remarkably full life, working, marrying, and raising a family the entire time. Most ordinary hiccup bouts, thankfully, resolve within just a few minutes on their own. Hiccups are actually one of the most searched everyday health topics online, right behind more serious conditions. Okay, let's bring this all together. A hiccup is a sudden diaphragm contraction paired with a rapid glottis closure, coordinated by specific nerves. One of the leading theories traces this reflex all the way back to our amphibian ancestors' gill-breathing days. The unusually long path of the phrenic nerve offers a second clue pointing toward that same fishy ancestry. Fetal hiccups may help practice breathing muscles before birth, connecting neatly to this same deep history. And modern science has finally caught up, with an actual tested device shown to interrupt the reflex effectively. All from one tiny, involuntary jolt almost everyone has felt, but almost nobody stops to actually question. If this answered a question you never knew you had, that's exactly what this channel is about. So if you enjoyed this, hit subscribe so you don't miss the next one. It genuinely helps this channel grow, and it takes about 2 seconds. Drop a comment and tell me which part surprised you the most. Was it the tadpole connection? Charles Osborne's story? Let me know. And if you like this video, go ahead and tap that like button. It's a small click that genuinely helps this channel keep growing. There are hundreds of everyday questions just like this one waiting to be explored. Things you've experienced your whole life, but never actually questioned. That's what this channel is all about. Toggling your curiosity on, one question at a time. One more thing before you go. Tap that notification bell too, so you actually see it when the next video drops. Next time, we're tackling why flamingos stand on one leg for hours without falling over. It's a surprisingly clever energy-saving trick, and you will not guess the mechanism. I'll see you in the next one.